Hello everyone, my name is Paul and welcome to another episode of Radpow. In today's video we are going to be working on a PlayStation 3 Fat model, backwards compatible. This one is CECHB01 with classic YLOD, yellow light of death. First we're gonna use our UART converter to fully diagnose this board and confirm if this is really YLOD. If we're gonna confirm this is our yellow light of death, we have another PlayStation 3 Slim model for parts. This one is also broken. It has a bad USB ports, as you can see here, but it still have a working RSX GPU, which we're gonna use to revive our old Fat model. So in this video, I'm gonna show you how to salvage a working GPU, reball it, and solder it into our patient. So welcome, and I hope you're gonna enjoy it. So first let's focus on our Fat model, take it apart. I am not going to bore you disassembling this device. There are many videos on YouTube how to take it apart, so we're gonna see whenever the board's gonna be out. Just one thing to show you guys, this console wasn't taken apart before this one. Actually, I didn't show you the real problem, but the console is turning off right away. You can see whenever you're gonna turn this on, you have a red light, and it turns off immediately. So this shows our yellow light of death. Okay, now we have our board out. Always use some piece of foam, thick foam, to have the board flat on your table, because you have these connectors for power supply. Try not to bend this board. Most likely our issue is with this chip, which is RSX GPU. But first let's connect our cables and do the syscon read and check our errors. Here you can see the test points we have to solder our reader to. We have to solder our ground, RX, TX, and diag, which is diagnose cable, which we're gonna then solder to the ground. But first we will have to go to our command prompt and use syscon reader. So to make the soldering easier, you can tin the pads first. We need a ground pin, which we can take here, our RX, TX, and diag. Let's solder our test points. Let's solder the diag too, but do not connect it to the ground yet. After soldering the wires, we need to connect our power supply. So I am using a piece of foam to separate the board from the power supply and connect to the board. Let's connect 5 volts and connect our power cable. Turn the console on. Now, whenever we are in internal mode, we have to check our EEPROM checksum. The command is EEP-CSUM. As you can see, we have a problem at the address of 39FE. We have to write it to 38F0 because this is little endian byte swapping. Let's do it now. This is our command to fix the EEPROM checksum. Write complete. Now we have to validate the change with this command, R39FE02. This is a correct one, so let's go further. Now we can check our EEPROM checksum with the command EEP checksum again. Now, as you can see, we have no other issues here. The checksum is fixed. Now we can use error log command to see what errors does this console have. As you can see, most of the time we have 3034 error and 1001. 3034 means this is something wrong with connection between our cell and RSX. Most likely RSX is dead, so we have to replace it. 1001 means our NUC tokens needs to be replaced too. For now we can put our board away for now, and now we're gonna try to salvage a working RSX chip from our Slim model. This time I'm not gonna bore you again with taking this apart. If you want to see a tutorial how to take a PS3 Slim apart, you can find it on YouTube with so many videos. So let's see whenever the board is out. So we are back, and here we have our board, our donor board to have an RSX to be salvaged. Beside RSX, what we're gonna take out from this board is a voltage regulator needed for a voltage drop down for a newer version of RSX. This is a 3300 version of RSX, and also we're gonna use tantalum capacitors to make tantalizers for our PlayStation. So now let's go to our rework station and take the RSX out. So now we have a view from the rework station, and now I'm going to show you how I do prepare it to take out the GPU chip. We have to add our thermocouple. That probe is so thin that we can put this underneath the chip, so the temperature is going to be taken underneath. So this is how our rework station looks like. We are having a PC410 controller and REX C100 to control the temperature. The whole process takes around 7 minutes, so I'm gonna be back by the end of the process to show you how I remove the chip. Whenever we are having a temperature close to 100 degrees Celsius, we can add some flux to it. Now, whenever the solder is molten, we can poke the chip and check if it's moving. If it's moving, it's ready to be removed. So we have our chip removed, and whenever the board is still hot, it's going to be easier for us to remove our capacitors for tantalizers. As you can see, I am using thermal tweezers and some leaded solder to remove these capacitors. So it's still not that easy, but whenever that board is still hot, it's still easier than doing it on a cold board. So let's remove all of these caps. We're gonna reuse them, as I said, in our tantalizers. I will also show you how I am making them. Also, we have to take the small ceramic capacitors too. It's gonna be easier with the tweezers to take them out, because they are sticking to the tip. But we have to use all of them. And this we will use to replace our neck tokens. If you are having problems to remove these caps, we can always help ourselves with the hot air from the top. It's going to be much easier to take these caps because the PCB is cooling down and it's really hard to take them out. We don't want to damage them too. That's why we are using hot air from the top. So beside tantalum capacitors and ceramics capacitors, we're gonna also salvage one voltage regulator, which is 0.95 volt regulator needed for RSX. Same thing here, we can help ourselves with a hot air station. As you can see, the chip is out. Also, we have capacitors on the other side of the board, but we can do the same thing to salvage them using thermo tweezers and sometimes hot air. We're gonna take them all out as we are going to use them for both RSX and cell GPU and CPU on our Fat model. We have all of them needed here, so let's take them all out. These are all components needed for our Frankenstein mode to be salvaged from this board. One more thing to mention, we have here our MX TSOP memory. This can also be salvaged in case you're gonna have a red screen of death, because to fix it we will need a new memory, but this is a topic for another video. If you're gonna be interested, please let me know. I will also show you this one. By the way, leave a comment below and tell me which parts are you salvaging from this board beside the ones I showed you. So now let's take care about our GPU, our RSX chip. We have to remove all old solder from the bottom of the chip and do the full reballing. And now I'm going to show you how I am doing it. First, let's add some flux and remove all of that lead-free solder. This should be enough. First, let's add some leaded solder and try to remove it. Let's make a solder blob and just slowly melt and mix both solders, lead-free and leaded. Sometimes if you want, you can also use a low melt with bismuth, but it's not needed. A regular leaded solder should be enough. So let me clean this one and then I'm gonna show you the next step. This is how the chip looks like with solder balls removed, but now we have to use a solder wick to remove completely this old solder. So to remove solder, I am using this Towat solder wick, which is 2.5 millimeter wide, and let's try to clean it. Gently, try not to scratch it too much, and do not hurry. This has to be done really well. As you can see, this solder wick sucks the tin, that solder, pretty well, but you have to move on. If it's full of solder, just take another spot, a fresh wick, and clean it fully. So, as I said, this takes a while. Don't hurry. If the wick will stick to the chip, do not move on. Heat this up. Try not to rip any pad off. So, as you can see, this chip is going quite well. The temperature I am using is 300 Celsius. Maybe that's how it's going so well. Okay, now let's use some isopropyl alcohol to clean the chip. First, let's spray it here, give it a few seconds to soak, and we can cover it with a piece of cloth and spray it again. Give it a few seconds. I'm gonna remove my gloves so I'm not gonna make them even more dirty. And now we can clean the chip and see how does it look like. So it's going quite well. This is our chip after removing the solder. All the pads are intact, are in really good shape. So now let's use our stencil and do a full reballing. So as I showed you in one of my previous videos, for reballing we are going to be using our 0.6 millimeter solder balls, but this time we're going to use a Styri ASMTF Tachyflux. Let's find out if it's worth it something. So first, let's put our chip into the stencil. Let's use our screw to firmly hold it in place, and let's find out if our holes match. We have to adjust it a little bit, so let's unscrew it and make all holes be fit and match the soldering points. Now you can see, I hope they are all matched. So now let's add some flux and spread it with a brush. Don't put too much, otherwise your balls will join together. Let's spread it with a brush evenly, and every single solder joint or solder pad has to be covered with a minimum amount of flux. So you can brush it a couple of times over it. Let's leave a thin, even layer of this flux on this chip. So now let's put our stencil on and add some balls. Hold the stencil firmly and just wiggle it, so every single hole will have its ball, and take out extra amount. Always close the lid so you won't just lose it. Now let's find out if every hole has its ball. Unfortunately, we are missing some, but we have some extras here, so we can use tweezers to put them in place. There are not so many, just a couple. So let's put them in. If they are sticking to your tweezers, you can use some clean cloth and clean it, always with alcohol, and then they should not stick anymore. One more here. At the end, under the microscope, we can check if every single hole has its own ball, or anything is, or we don't have any extra ones. As you can see, this one is quite okay. So let's try to take the lid off. Now, after our visual check and confirming everything is fine, we can wiggle the top a little bit and try to remove it. Okay. Now we can see if every ball is on its place. After removing the lid, we can also double check under the microscope if there is any doubled ball or anything has to be adjusted. As you can see, this one is quite okay. We can try to melt the balls and try to solder to its place. For this purpose, I'm going to use my DIY hot plate. Because of the RSX chip has IHS, which is that metal plate which takes out too much heat. I don't want to re-hot it just with hot air station. That's why I want to preheat from the bottom. So now let's take the chip from the stencil and put this on our hot plate. Let's give it a minute, and after a minute we're gonna start heating it from the top with hot air station. So now let's start heating it from the top. Let's use round movements. Slowly heat the whole chip. If you're gonna see some balls moving and trying to join the other one, stop heating it and remove that ball, or try not to join them. As you can see, the balls are nicely aligning up, and most of them melting to its place. If you see any needed adjustment, just poke it with the tweezers. I can see some are moving and need to be adjusted, like so. It's better to remove some balls and adjust them later or put them back later than having them all joined, and that's going to be a problem. There are a few techniques to separate them. We can remove it with a solder wick. We can use a scalpel to cut them in half and re-hot it. But the best option is not to have any joint balls. Whenever all the balls are molten, but they are not really aligned, we can add some more flux and try to re-hot them again. They will realign nicely but whenever they are already soldered, they will not join together. Smoky. It's really good flux, that steery, but smoking a little bit. Now all of the bolts are aligning really well. They're nice and shiny. So I believe our reballing process on this chip is complete. Now let's take the chip out of my heat station hot plate and cool it down. Whenever a chip is cooled down, we can use a small piece of cloth and isopropyl alcohol to clean the chip from flux residues. The idea with the flux is all of that used flux has to be removed, because whenever it's activated, it won't do its job anymore. So now we can use a brush like so and use isopropyl alcohol. So add some alcohol and brush it to the side, all of those flux residues. You can see that this chip is really nice and clean. One thing to mention is whenever you're gonna remove the chip, you can check if it's quite green from the bottom. The greener the better. If the chip looks brownish, I can tell you right away it's overheated. So there is no sense to use it, because technically you are 90% sure that it was overheated and damaged. Also, we can use the same technique using a clean piece of cloth, covering the chip, spraying it, and just brush it from the top. All of that extra residues will be soaked by the cloth and alcohol. As you can see, no more residues are coming to the cloth, so I can tell this chip looks quite okay. If you see any spots needed to be cleaned, clean it again. Now I just want to show you the chip here. As you can see, everything looks really neat and nice. At the end, of course, always clean your stencil. Don't leave it for next time, because the flux will dry out and it's going to be much harder to clean it. I really like to have my old tools nice and clean, so cleaned for the next time. Also, we can check it under the microscope if all bolts are even and clean, nice, shiny. The solder bolts are leaded bolts, so they look completely different than lead-free ones. These ones are shiny. Lead-free are quite dull and matte. Now, whenever we have our donor chip, good chip done, we can go back to our Fat COK motherboard and remove the old broken RSX GPU. But before soldering, we have our board here. Before desoldering that GPU, we can train the syscon for a new 40 nanometer GPU, so we won't have to solder this cables again. Let's do the training now, and then we're gonna put our new chip in. So again, we are in command prompt. We have to go to internal mode, type authorize, and as you can see, we are in. To train the syscon, we are going to be using the following commands. Let's go back, enter. This one is for, this commands are for 40 nanometer RSX CXD 5300 or 5301. Let's do all of them one by one. Copy and paste. Now it's completed. Now we have to fix checksums at the address 32FE and 34FE. So let's use the command EE. So in this case, we have to write at the address W 32FE and write our A761, and for the address of 34FE, in our case checksum, and we should have no errors this time. I just found out that my OBS shortcuts was set to P, and every time I was typing P, it just paused my recording. So what I've done so far, you're gonna see here, I type write 34FE DED2, hit enter, and it was completed. Then we checked that EEP checksum CECHB01 again, and now as you can see here, there are no errors anymore. So now with the new chip, the console should turn on easily without any errors or triple beeping. So we are back at our console. We can turn this off and unplug everything. From here, disconnect power and remove our power supply. Now let's desolder our cables because we don't need them anymore. Okay, let's put this away. Now we're gonna do our resistor mod needed for that. So for our resistor mod, we have to remove R2001 and we have to remove R2054. Scratch solder mask next to that R2054 make that ground pad, and then we have to use 10K resistor taken from other spot as you see on this picture. So move R2153 10K to that spot we made the ground plane. So let's do it now. To remove that R2001, we're gonna use the thermo tweezers. Let's find out if that's gonna work. Interesting. If that's not gonna work, we're gonna use regular soldering iron. Just add some more solder and we can easily remove it. Same thing with R2054. Let's take it out. We don't need it, so we can get rid of it. Now we have to scratch a little bit of solder mask here. When we have it scratched and some copper exposed, we can tin this spot. Now we have to move our 2553 to the spot we just made. Whenever we have it done, we can go to our soldering, our VGA rework station, and remove our chip from here. For this purpose, I made a jig. So let's put our board into the jig and put some screws so the board won't warp under the heat. Because if you will not do it and you will try to hot it from the bottom, the whole board will just bend up. So all the screws are in from the board to the jig. One thing to mention, I didn't purchase this jig, I made it myself on the CNC machine you can see right behind me, probably in this spot. So let's go to the VGA rework station and let's meet there. So again, we are at the rework station. As you can see, again we have to attach our thermocouple, tiny one, probably you won't even see it, under the RSX chip. So slide this underneath and just tape it behind. Now again we can go back to the upper heater and start our profile. So again, let's wait until this chip gonna heat up. One more thing to mention is the whole process is controlled with this PSoft software. So everything, this laptop is connected to my DIY rework station. You can see here, it's been made on the base of T8280 preheater. So this one is controlled with this laptop. Whenever our temperature gonna rise to 100 degrees Celsius, we can put some more flux. It's not that easy to squeeze the syringe. But we have to add some flux from every single side. You could see my hands shaking, but I've been trying to squeeze the syringe. I don't want to use a brand new flux just for desoldering purposes. I'm using some old non-branded flux for this purpose. Whenever the temperature is reached, we can remove the chip. Process complete. Now, whenever the chip is removed, let's clean the solder. I don't know what happened to my neck tokens, but we're gonna remove them anyways. So I believe they were broken before, so we'll see. Now let's remove that solder and mix it with a leaded one and see if we're gonna clean the pads. So let's add some leaded solder and clean the pads as the board is still hot. Gently and slowly. So as you can see, whenever you're gonna have a solder blob, you can just push it away. Okay, let's move on slowly and gently. one thing I would like to show you are these gray pads. They are oxidized, so we have to scratch them a little bit and add some more fresh solder, otherwise the ball will not stick to it. So let's continue cleaning the board and I'll meet you in a second. I just noticed I unfortunately moved one of the resistor ladder. We have to fix it. So what we can do, we can just add to its pads some leaded solder, which will make much easier for us to solder it. And just use hot air station and try to move it to its place. It will take some time to heat this board, as it is multi-layer, thick, really thick board. So just be patient. Heat surrounding area, and whenever it's gonna be molten, let's put this in place like so. As you can see, it's on its place, so it should be okay now. At the end, we can also use our soldering iron just to resolder from both ends. As you can see, now it's on its place. One more thing I noticed, at each corner of that RSX chip we should have a tiny positioning resistors or capacitors. They are not doing anything, they are just here to make a distance between the PCB and that RSX chip. These are 0.0201 in size of SMT components, so we're gonna replenish it later. Now again, using a solder wick and our soldering station, let's clean the soldering pads using a solder wick. Slowly remove the solder and clean all of the pads. Do not hurry up, otherwise the solder wick will stick to one of the pads and you're gonna rip the pad off. It's not that easy to fix a ripped pad. It's still doable, but you have to be very skilled and experienced to replace a BGA pad. Technically, you can also fix it with a string of the wire from solder wick. It's thin enough to make it to fix that pad, but oh, I'm putting my head so you won't see what I'm doing, but slowly clean all of the pads so everything gonna be flat. Because remember, if you're gonna leave anything here, you won't put a sphere on another sphere, so it won't stick or you won't be able to position the chip properly. I can see one more oxidized pad, so let's put some more solder to it and fix it. Okay, now it should be fine. Let's clean it again. Okay, let's use some fresh wick and it's gonna be completely fine. Okay, now of course again isopropyl alcohol and some clean cloth. give it a couple seconds, let the chemicals work. We can try doing it from the top. As you can see, this tiny cloth is sucking the flux residues out. Let's take the glove out and clean the spot. Sometimes it needs some more rubbing, but you have to clean it really nice. It has to be really clean. You cannot leave any dirt, otherwise all of the work will be for nothing. Let's put some more alcohol. Use a clean spot and just wipe it out. Oh, I see some spots which weren't cleaned properly, so let's fix it now. Here, make the spots flat. Okay, nicely. Oh, I don't think we're gonna see it. Okay, now you can see the spot. Unfortunately, these two have to go out. So we're gonna do it now. To remove neck stockings, I am using this type of sharp spatula. So just slide it underneath and mechanically rip off, take it apart, and take the whole thing out. As you can see, I am keeping the board in the jig, so I'm not gonna bend it and damage it. Okay, this one's out. Let's take the other one too. Don't push too hard. It's better to just lift one side and then lift it completely. As you can see, sometimes it's not that easy as it looks like. Try not to bend the board too much. Okay, it's done. As I mentioned, on every corner we're gonna use that 0201 resistors to position the chip. So all four corners needs to have it. Let's use our soldering station and try to solder it in place. Believe me or not, but this is really tiny. Try to solder both sides, otherwise you may have a situation whenever it will stand up and block the RSX chip to sit properly. Let's do all three other corners. Whenever we have all four corners done, we can solder our RSX. So first let's add some flux, spread it with a brush and position the chip. Again, spread it really evenly. It doesn't need a thick layer, it just needs a tiny bit of flux. But as I said, it has to be all even. Of course, then we will position it here. Remember about the chip and it's pin number 1. So let's try to position it. All of those resistors we just soldered are our position points. Now we have our board on the rework station. Thermocouple is under the chip and we can start our profile. The whole process takes around 7 to 8 minutes. If you are interested in my settings, like my profile, or you want to know something more about that PSoft software I am using to control the station, leave a comment below. In the meanwhile, we can solder our tantalizers. I am using PCBs ordered in China to make our tantalizers, and I am using capacitors salvaged from that board I showed you before. So we have to do 8 of them to put on a board here. Now we can temporarily attach our heatsink, as you can see here. I attached it. I used some spacers and our power supply. Let me just zoom out. As you can see now, I tested it for shorts. It has low resistance, but still it's acceptable because RSX has really low resistance, especially whenever it's hot. So let's connect it to HDMI port and a TV, and let's test it. So now with the PS3 connected to our TV, let's try to turn this on. We have a green light, so let's see. You can see that it was detected on our TV. We are having an image now, so our process was successful. Let's wait a little bit. Yeah, we are having an image. Of course, this console doesn't have a hard drive, so it won't boot, but at least we know that we have an image. As you can see, as the spacers, I am just using a piece of cardboard. This is just for testing purposes, so it doesn't have to be done really well. For now, let's cut, with this tool, let's cut all of other NEC tokens, replace them and test the console again. And with this one, we will also remove IHS, that metal plate, from a cell CPU. So as I said, to remove NEC tokens, we will mechanically break them apart and cut them out. As you can see, whenever you're gonna go underneath this pieces, you can cut the solder easily. Just be careful, do not rip any other components here. Try not to scratch it too much. As you can see, it's not that difficult. So let me do all others and solder that tantalizers and tantalizing gonna be done. So all of those NEC tokens are removed. Now let's solder our tantalizers. This one has to be cleaned better. Okay, let's use a scalpel maybe. As you can see, it's easy to cut this out. Oops. I just moved my camera by accident. Okay, so let's try to solder one by one. Do not make any shorts or bridges, however you want to call it. Just so let's just solder some points to hold it in place, and we will come back and use some hot air station to help us. This laminates for PS3s are quite thick and they are not that easy to solder. So sometimes you need to help yourself with some other methods, and the easiest one is to use hot air and preheat the board a little bit, or just heat everything here, and yeah, this should help. Oh, oops, I didn't. This is exactly what I'm talking about. Is soldering pads are quite thick and the ground planes are huge here, and you have to use some more force. Saying the force, I'm just have a heat in my mind. Let's put some flux to make it easier to make that solder flow better. And I just moved this one. Okay. Add some more solder at the side. And as you can see, even this soldering station is really powerful. Sometimes this tip sticks to the PCB. That's why we have to help ourselves, as I'm gonna just show you in a second. I just want to put some more solder on the pads. Oops. Don't go anywhere. Okay, so let's use some hot air and reheat and heat this area. As you can see now, the soldering process is much easier. Let's put something here and there. Okay, let's put some more to this spot. More solder here, and let's work on this ones here. Be gentle, don't press too hard. We don't want to scratch anything. Or also be careful, do not make any shorts. I know that I am talking the same thing like round and round, but I just want you to know to be really careful with that. You can use some hot air. I believe we need some more flux. Okay, round movements, as you can see now. Don't make shorts, as I just did. Let's fix it. Same thing here. Okay, this should be okay. At the end, we're gonna measure it if there is no short. Okay, we have two more tokens on this side to remove and solder tantalizers. So let me remove them now. And there is gonna be one more thing to do, I forgot. We salvaged a voltage regulator from Slim PCB. We have to use it to extend a lifetime of that neck token we just soldered. So we have to lower the voltage to 0.95 volts. So this RSX gonna be powered from the voltage it was designed to, because the difference between 90 nanometers and 40 nanometer RSX is that 40 nanometer one is powered by 0.95 volts. Correct me if I am wrong, maybe. Okay, again, just cut in between. Okay, see, it goes underneath quite easily. Sometimes we need to use some force to do that. Okay, let me just solder those tantalizers. So the last part is here. You have this this voltage regulator in here. It's this one. We have to replace this one. We salvaged. Previous picture was where we took the chip from. This is the place where we have to solder it, and as you can see, we have to solder it here, lift this 3 pins, and 2 middle ones connect to this capacitor here. This way we're gonna get that 0.95 volts required for a 40 nanometer RSX. So now let's use our thermo tweezers again and remove this chip from here. Oh, my light is falling down. Okay, let's try to remove this chip here. Chip removed. Clean the solder. Okay, let's wait till it's gonna heat up. And use some solder wick to clean the pads. Oh, sticking. Just be careful. And of course, I will say it again and again, clean it. Don't leave flux residues on your board. This way your work will look professional. As you can see, this regulator was soldered and the jumper wire was added. Now let's clean everything and test it again. As you can see again, I am using my cardboard insulators here. Let's test it again. As you can see, it's working. So we have our RSX replaced, all NEC tokens replaced, and that voltage regulator is also replaced. So in this video you could see the whole process, how I am doing Frankenstein mode on PlayStation 3. Every single PlayStation old Fat model from CECHA to CECHE is backwards compatible. It's worth it to save it and replace that RSX GPU. This video might seem to be chaotic, but please forgive me. This is my first times on YouTube. I'm not that fluent in it. I'm sorry for my English. This is not my first language too. So, but still, if you would like to see more videos like this, give me a like, give me a subscribe, and leave a comment. How would you do this process? Which tools are you using? What temperatures are you using on your stations? And if you would like to hear something more about the tools I'm using, like my rework station or my soldering stations, the software I'm using to control that BGA rework station, let me know in the comment below. I hope you enjoyed it, and see you in the next one. Thank you. Bye.